Hi everyone! In this video, I'm going to show you how to do general inverse functions for sine, cosine, and tangent in 360 degrees for arbitrary angles and arbitrary sides. So the last video, I showed you guys how to do special triangles, you know, your 30, 45, 60 triangles, and your 0 and 90 degree rotations, right? All the special things that we can find the exact values of. In this video, I'm going to show you how to handle angles that aren't those special values, and sides that aren't special side lengths, and work backwards to find those angles. So first of all, let's just jump in a quick recap of how we do an inverse operation. Let's say we have theta equals cos inverse of negative root 3 over 2. So the way we're going to handle this is by starting to sketch our grid. Negative root 3 over 2 is wide, and it's on the x-axis because it's cosine, right? So this is our x value. So negative root 3 over 2 is over here. And there's two possible triangles that have negative root 3 over 2. The wide triangle in the second quadrant and the short wide triangle in the third quadrant. So straight left is 180 degrees. And since this is the wide triangle giving us our negative root 3 over 2, then we're going to have 30 degrees back or 30 degrees past 180, which makes this 150 degrees or 210 degrees. So this tells us that theta equals 150 degrees or 210 degrees. Okay, so this one worked out nicely for us because root 3 over 2 is that special value that we all know and love from the x value of our 30-degree triangle. Now, what if I give you one that's not so nice? What if I ask you to do theta equals sine inverse of 0.7? 0.7 isn't a special triangle. So how can we figure this one out? Turns out we can do it basically the same way, except we're going to use the calculator in the middle. So we're going to start here. 0.7 is here. Now, remember when you're drawing triangles, you always draw from the x-axis. That's a mistake that students sometimes make with inverses. So we want to draw our triangles up on both sides. That's 0.7 tall. 0.7 tall. And we need to figure out what angles, right, this angle here, and we need to figure out this angle here that can give us this triangle. And our calculator can help us with this. What we can do, first of all, let's make sure that we're in degree mode. Yeah, okay, good, I'm in degree mode. So since I'm in degree mode, I can do second function sine to get sine inverse, and then I'm going to put in my 0.7. So sine inverse of 0.7 gives me 44.4 degrees. Now, that's only going to be this one right here, 44.4 degrees. And if you recall from my last video, I talked about what your calculator does for inverses. Your calculator for sine only gives you the right half of the circle. So the left half of the circle is completely ignored. But this one correctly gives us our 44.4 degrees over here. Now the question is, how can we figure out this angle over here? Well, that then is going to be 44.4 degrees back from 180. So 180 minus 44.4 is 135.6. So theta equals 44.4 degrees or 135.6 degrees. And this one worked out really nicely for us because it was a positive value. The inverse function gave us our first quadrant angle, which is our reference angle, the standard reference angle that we're used to using. And same thing would be true for cosine. Cosine, so this is the range of sine inverse range, and then the cos inverse range is the top half of the circle. So again, if we put a positive value in for cos inverse, it's going to give you something in the first quadrant, which is nice and easy to use. Okay, what if I give you something that's negative though? What if I say that I want theta equals cos inverse of negative 0.8? Okay, this is going to be a bit of a problem for us, and we'll see why in a sec. It's not too bad. It's not too hard to manage, but you need to be careful with this. So negative 0.8 is over here. let's say. So that's going to be wide. So we're going to get something that looks like this, I guess. And the diagram doesn't really matter as much because the calculator is going to tell us the angle anyway. So even if you draw this wrong and you draw it like this, it doesn't really matter. Your calculator is going to tell you how you've done it wrong. So not a big deal, but I know this is going to be fairly wide. So if I cos inverse negative 0.8, second cos negative 0.8, then my calculator tells me 143 degrees, which is fantastic. 143 degrees lets me do 143.1 degrees lets me do this second quadrant angle really easily. But that actually makes this angle much harder to figure out. Because now I need to figure out, okay, how much did I go back from 180 degrees to get 143.1 degrees? Because then I'm going to need to figure out how much I went back to then be able to figure out how far forward I get. And this isn't going to be 143 degrees down here, right? It's going to be less than 40. It's going to be, I don't know, 20 something degrees, 30 something degrees, right? We're going to need to figure out what that value is. If your mental math is strong, you can figure it out. But there's actually an easier way you can do this. And what the easier way to do this is to just ignore the negative sign. So basically, never put negative values into your inverse trig functions. And if you never put negative values into your inverse trig functions, then you're always going to get your first quadrant reference angle. So let's try that instead. If I did instead second cos of positive 0.8, so the exact same value, just positive, then cos inverse of 0.8 is 36.9 degrees. And that is your reference angle. That tells you that this is 36.9 degrees and this is 36.9 degrees. So then theta is 180 plus or minus, right? Going back or going forwards, your 36.9 degrees. And that's fairly easy to do then. Theta equals 180 minus 36.9 is 143.1 degrees. That's one we already had. But this is what it really lets you do. It lets you do your 180 plus 36.9 degrees really nicely. Or 216.9 degrees. Okay, so you could have figured this out. You could have actually done 180 minus 143.1 to get your 36.9 and then done 180 plus 36.9, and that's fine. But I've seen so many students make so many mistakes with this that I think the easier way is to just get your first quadrant reference angle every single time and then just work, forwards or backwards from 180 or forwards or backwards from 0 or 360 as usual. And I think that's a little bit more straightforward. Okay, let's try another one for tangent. So let's do tan inverse. Let's do a negative slope. Let's do negative 5, because tangent can be steep, right? You can have a slope as high as you want. Sine and cosine are only defined between 0 and 1 for the range of the sine and cosine function. So your sine inverse function and cos inverse function can only take values between negative 1 and 1. But tangent can take any value at all, basically. So let's do this. What I'm going to do is I'm going to do second function tan of 5 to get my reference angle. So I know that a slope of negative 5 is going to be something steep like this. And I know my reference angle is tan inverse of positive 5, which is 78.7 degrees. So this angle then here is 78.7 degrees back from 180. And this angle here is 78.7 degrees back from 360 degrees. So if this was theta, then theta equals, so take 80 away would mean 100 even. So it's 101.3. Or 360 minus 60 would be 300 minus another 18 will be 280. Shoot, I just meant, let me double check the calculator. No shame in using a calculator. And here I am in video, and I just had a mental math fail. No, I was right. 281.3 degrees. I just didn't have confidence in my mental math. Okay, so there are your two possible angles for tan inverse of -5. Okay, we'll do one more for sine just for fun. If you think you get it, you can just skip the end of the video now. But I'm going to do sine inverse of a negative. Let's do sine inverse of something. Let's do something really small. Let's do -0.1. Okay, so what I'm going to do is sketch it. -0.1 is like something like this and something like this, because that's -0.1. So I'm going to do sine inverse of +0.1 to get my reference angle. So second sine of, no, not 1, 0.1 gives me 5.7 degrees. So this is 360 degrees minus 5.7 is 354.3. No. Yeah, no, that's right. 354.3 degrees. And this is 180 plus 5.7 is 185.7 degrees. So those are your two possible values. 185.7 or 354.3 degrees. Okay, so that's how you can do non-special triangles or non-special angles from your sine, cosine inverse.